apparatus. This can you see. Okay. This is the basically the meant for non-thermal techniques, which is used for the extension of shelf life and preservation, as well as the microbial inactivation of the fresh fruits, meats, grains, pulses, anything you know, in respective of food products. Basically, this is for the solid foods, any type of solid grains, pulses, meat, all these things, and this is for the liquid foods, plasma activated water. You can place the liquid, any type of liquid, slurry, and juice for the inactivations of microbes, enzymes, as well as to extend the shelf life. And in conventional methods, you have what we will do for the preservation. We will sun dry, we will heat, means give the heat for the about a certain period to kill the microorganism, pests, insects present inside the grains and pulses. I am emphasizing this type of foods. But in that conditions, in conventional preservation techniques, there is a basic demerits that it will also reduce the nutraceutical properties. Nutraceutical means it will has nutraceutical values, bacterial compounds, as well as volatiles, and so health benefits, which is reduced by the uses of temperature. So our main target is to minimize the microorganism counts and reduce the pestle insects present in the water, but as well as to preserve the all the nutritional properties, and also in by both doing will also means extend the shelf life of the product. Suppose we have grains, fresh grains after the harvesting, we have grains, and we give cold plasma to it, and it will store for certain if the conventional means if the uncontrolled means there is no applications of a cold plasma. If it is stored for the 6 months, then after the cold plasma our intent to be stored up to more than 6 months, that too with the storing its a nutraceutical properties. Okay, got it. And it is a non-thermal property because the application is during the application the temperature is nearly and is equal to the room temperature. So there is no reduction of the health its potential bioactive compounds and the volatiles present in the whatever your target samples you are from. Next, here's mechanism क्या है ना, it uses the gases, mainly the noble gases, inert gases like helium, nitrogen, hydrogen, all this, and you can also use the atmospheric gas also. It mainly uses these gases, and by the high electric field discharge it will convert into the ions like ozons, single oxygen atoms, all these things which can penetrate into the microorganism cells, pest cells, and insect cells, and it will kill the organisms by hampering the cellular metabolism. So this in this we have to put the sample here. We just give a certain voltage like 20 kilovolts, 30 kilovolts, basics of on the conditions which we are applying on the pulses, grains, and how much time it should be in the 5 to 10 minutes, means not greater than the 15 to 20 minutes. It is very minimization time process. By the means सपोज दिस इज कैन सिंपली टेल बाई चुटकी से हम सेल्फ लाइफ भी एनहांस कर सकते हैं. So this is the right process. In plasma activated water, same procedure, same mechanism also applicable, but it is applicable on the water. Means whatever the ionization is produced, it will give to the liquid foods, and these ions in the ions present, it will go to enjoy, means supply to the liquid foods, and it will also kill the means microorganisms and fungus, all these things whatever hamper our fresh produce. He's our in one of the PhD students, Sivasis. He will demonstrate you the cold plasma means how the equipment design, all these things, and also the advantages and disadvantages of it. Our samples is we took the rice, it is infected, already infected. We will see how the
this cold plasma could be conveyed through this conveyor belt, and at meanwhile the plasma generated will be forced on this food product for the decontamination of either these insects or microorganisms. So as you can see, this one, this is one electrode, and this one is another electrode. So this one is connected to the live wire, and this one is the grounded one. So this is actually multi-pin type cold plasma reactor. As you can see, so many pins are there. So these pins are made up of stainless steel, and total 63 numbers of pins are there, 7 by 9. And the main mechanism is like, so for instance, suppose we are using cold plasma, mainly three types of cold plasma means, based on pressure, three types of cold plasma could be generated. One is at atmospheric pressure, one is below atmospheric pressure, and another one is above atmospheric pressure. So this one is at atmospheric pressure we are doing, because for instance, below atmospheric pressure, uh, the chamber needs to be sealed, means there should be no leakage, or else that pressure below the atmosphere pressure that can't be maintained. So here what happens? So air is actually a bad conductor of electricity, but when we apply voltage, for instance, here the lower limit is 10 kilovolt and the highest is 30 kilovolt. So once the voltage reach around 10 kilovolt, the dielectric constant um, changes, and the gas, after that the gas acts like a good conductor, because of the formation of ions. Ions are basically charged particles, right? So because of that only, the gas acts like a conductor, and this gas, mainly reactive oxygen species and nitrogen species, which are formed during this cold plasma reaction, are the main reason behind this disinfection of microorganisms and insects and all. So in the reactive oxygen species, uh, ozone ozone comes, then single oxygen atom comes. Uh, so one more thing is like, what are the parameters we can vary in this cold plasma reaction? One is the electrode distance. Okay. So other one is the feed gas. So currently here feed gas is our atmospheric air only. So that composes of 78% of nitrogen and 21% of oxygen. But in case if people, there are certain studies where noble gases like helium and even pure nitrogen gases have been used for as a feed gas. And one more thing is flow rate. So here one blower is there. One regulator is there from where you can change the speed of the flow rate. So three parameters gone. One is electrode distance, one is feed gas, and there is flow rate, and two more things like voltage. Like I said, the voltage could be ranged from 10 kilovolt to 30 kilovolt, and time as per your requirement. Uh, so total five parameters we could change here. Mm, okay, so this is the control panel here. From here itself we are going to vary the uh, uh, voltage and time. So we are going to treat this infested insect infested rice kernels at 30 kilovolt for 10 minutes. So we are going to place this between these two electrodes. Okay, as you can see, right? This one is the ground electrode. This one is the live one. and this distance is 7 centimeter, working distance 7 centimeter. So here we have to see, turn it on, that says high voltage on. Time is 10 minute already fixed before only. Here you have to check, once it come to once, that means 10 kilovolt, and once it comes to 3, that means 30 kilovolt is reached. So once the voltage goes beyond 20 kilovolt, this hissing sound starts producing. So here now the countdown starts. So this LED light will blink once for 6 seconds. So this is the picture you can see. Means now you can't see the gases being produced. So once the light is off, so this is what formed uh, in that reactor. Okay. So other than, like I said, reactive oxygen species are produced. Similarly, ultraviolet rays are also produced because you know means, in this reactor the atoms they get excited. So once they get enough energy, so they get excited. So from excited state they again come down to their ground state. So meanwhile they shed their excess of energy in the form of this UV light, UV photons and all. So as you know, UV means it is quite effective against microorganisms. Even in our aquaguard and all, UV filter would be there to disinfect the water. So main thing how UV light works means it changes the sequences of the genetic material of the microorganism. So that's why, so means they won't be able to reproduce furthermore. So that's why they are usually to polygenic death. So that is the reason behind means that is how whole plasma is effective against these microorganisms. So they are similarly, like Madam said, that is the plasma activated water reactor. So here also, like in is one electrode. This has to be put here. One uh, one separate casing is there where this has to be kept, and outer side, as you can see, there one metal strap is there, right? Okay, so that will act as the another electrode. Means for this one, if this one is the live one, positive one, the other one would act as grounded one. So here from beneath the one pipe is there. Through this water will be sent, and this one is the outlet. So through this way the water has to come out. But meanwhile, what will happen? So that metal strap is there, and this one is the water will actually flow in this annular space provided here. You can see, right? So like outer the strap is surrounding this whole circumference of the tube. So the plasma will be generated in radially. It's whole circumference it will cover. So meanwhile, when water will pass through these annular spaces, it will get charged, and that plasma activated water could be further studied for various purposes, like for decontamination of food products, or for even these are nowadays used for in irrigation water as well, because it is said that this plasma activated water is would be rich in nitrates and all. So plants require mostly three kinds of nutrients like NPK, nitrogen, phosphorus, and potassium. So this nitrogen plants require mainly nitrogen in the form of nitrates only. So that's why this plasma activated water now are being used for irrigation purposes also. Moreover, even this plasma activated water has been used for uh, accelerating the germination of seeds and all. Uh, so here is one picture. So you can see this is how plasma is generated inside a plasma activated water. Yeah, initial investment would be high. So once you start producing in a mass scale, in a larger quantity, then uh, uh, no operational cost in the sense for electricity you have to provide, because you see this is our household electricity only we are using 220 volt we are using, and we have transformer is there, so step up transformer is there to step up the voltage. So there in electricity there will be no issue, but like I said, in initial investment would be higher because the equipment itself would cost too much. But once uh, it is still there, thing is like you have to optimize the means, what like I said, either the what working distance has to be changed, or the flow rate has to be increased, or the treatment period at least we could change, because the voltage was maximum 30 kilovolt. We can't go beyond that. So one way you could reduce that is by increasing the treatment period.